so we're going to start with our notes, and we're going to finish up that weird overlapping triangle problem. That was the thing that we didn't finish, right? And that's why we didn't, and we didn't do our flashcards. So there's a bunch of things that we didn't get to because we spent a good chunk of time on the homework. But there was just other stuff that we worked on. Okay, so this is where we were. I'm going to just back out for a second and kind of reintroduce. So this is page 10. Okay. So find page 10 in your notebook. Okay. All right. So look, we're just going to finish up the notes on page 10, okay? All right. So this was the scoop. We had on the previous page use the opportunity to talk about vertical angles and why that's a nice, easy point to get on the Regents exam if it exists. Now, the problem with vertical angles is they're made anytime lines cross. And guess what? We're going to have more shapes and more diagonals and things happening. And so we have vertical angles in pictures a lot, but it doesn't necessarily mean that they're part of the problem. So this was a situation where we all talked about how we see 5 triangles. And when we actually examined the 2 triangles that were in the problem, we figured out that, none of them involve vertex E. And so, unfortunately, with these overlapping triangles, no vertical angles help us to prove triangle congruency. They just don't. The good thing is if you put them in your proof, you won't have points taken off, but you won't gain points either. So it's kind of like just a wash. Okay. So what we did last time, does everybody have these 2 pictures on their note pages already? Okay. So let's now digest the given. Okay. So, and we're going to digest it in both locations. So BA is perpendicular to AC. Remember, that's going to make our 90-degree angles. So it's right here, which means it's also, and this is the one I accidentally put in last class. It's right here. So we definitely have right triangles, or all right triangle. We go back here. DC is congruent to C, or perpendicular to CA. That's this 90-degree angle, which is this 90-degree angle. So the last thing they gave us was that BC, and now this is once again where things are hard. If I try to mark, and I'm going to use my highlighter just to show you, if I try to mark BC congruent to DA, it's really hard to do because right on the shapes because they're overlapping. So that's why you want to redraw, because now we can say, oh, BC is congruent to DA. I can use my regular hatch marks. And now what's interesting in this picture is actually what happened on the previous page. We have an angle, right? We have an angle that's kind of across from a side. So here's a set of sides, and here's a set of angles. I'm just going to put the A's on the inside temporarily. The A's are on the inside. So the thing is this it for information, and our vertical angles don't help us. But what does help us is both triangles have this. And now so this is the deal. If right triangles are on the page, you have to be like, ooh, HL could be an option. As soon as 2 angles are involved, though, you're probably letting go of HA. But here, we now have a right triangle with not a side anymore. We have the hypotenuse and we have the leg. So this becomes an H and an L. And this is our first HL proof. So that was the other reason why that homework was impossible. Because with an HL proof, it's a little bit different. I'm just going to go to the side area to kind of write one more thing down. That's not what I wanted. There. Okay, so on the side. Nope, that didn't work. Drawing. Maybe I just wasn't on the screen. There we go. So whenever we do things like angle, side, angle, right? We need 1 congruency, 2 congruency, 3 congruency, right? For all the ones with angles and sides, it's all congruency statements, right? So the problem is, for HL, you need 3 things, but it's a hypotenuse is congruent to a hypotenuse, and a leg is congruent to a leg, and then it's triangle. Ooh, that's not a triangle symbol. Hold, please. Undo. It's the last thing is not a congruency statement. It's saying triangles are right triangles. So this is your 1, 2, 3 things you need before you could do 4 HL. I know there's a lot of symbol talk. Does anybody need me to repeat what this really means because I said it really fast? Okay, so instead of having 2 like sides and angles, like in a proof, right, to do side, angle, side, I need sides and sides, but the sides are actually going to be just 2 sides. And then instead of saying I have congruent angles for the right angles, I'm going to say, hey, my triangles are right triangles. Okay? And then you can use HL. And so we're going to demo that now, proof style. This is just kind of an outline. Okay? So when you're ready, and what space you have remaining on your page, I'm just going to zoom out. We need to make our T-chart, right? So wherever you can use your straight edge, or I hope you're still using a straight edge, we're going to go make your T-chart like that. And you're going to put statements and reasons. And I'm going to write down the information they gave me in the picture. Or gave me, I'm sorry, in the given. So it's perpendicular, perpendicular, congruent. Looking for people to be ready. Josie, you ready? Okay, just making sure. Okay, so now we're ready for our second step. Let's deal with those perpendicular things next. Now, we did on a previous proof, we said a perpendicular bisector forms congruent right angles. You remember that one? Okay, so we can still do that, except we wouldn't say perpendicular bisector. We would say perpendicular lines form congruent right angles. Are you guys okay that I abbreviated right? You can write it out, but I just abbreviated it. The reason why we're doing this is because if we were going to be using the right angles as an A, you would be done at that point, right? So the angles that are right are BAC is congruent to angle DCA. You still have to call them with 3 letters because of the original picture. Okay. Now, this is where we have to add in something that's unique for HL. And this is the part that works. You ready? Now we would say triangle BAC and triangle DCA are right triangles. So why are they right triangles? Well, they got right angles. Literally, that's it. A right triangle has a right angle. So the step of getting right triangles in is a little bit clumpy. You almost need like 2 steps, right? Because you have to go from the perpendicular to the right triangle, okay? But now we can call this hypotenuse, can't we? Right? And all we have left to do is the leg. And the leg was the reflexive side. So AC is congruent to CA by the reflexive property. And right here, we have our congruent legs. All right, so this is why this proof is just a little bit different than the other type of congruency proofs, because it's 1 congruency statement, 2 congruency statements, and right triangles. Okay, so does that now connect to what we put in the side column? Okay, so now we can say our triangles are congruent. So I believe was it triangle? I can't remember the words.
BAC.
Thank you. Yep.
And DCA.
Okay. BAC, DCA. And it's HL. Okay.
When I did my thing, there was like erasers if you like try to go back to that was used. You just wrote.
Yeah.
For like the first one you just wrote for a picture, would I do like the two triangles?
So I think, like, it's, yeah, I mean, like, certainly drawing one of these pictures, like, and you might want this one because it's kind of like the idea of when you read A, B, bisect, C, D, kids make mistakes about which one is the one being bisected.
Okay.
So if you were going to draw the picture, I would draw the picture at the top of page 9. Okay. And then that's the one that's a little bit trickier because the bisect each other is kind of like, we bisect each other, we cut each other in half, you know,
Okay.
like not a big deal.
Yeah.
So I think we just have 2 cards to do, and I put the first one up. The second one has to do with our perpendicular lines. And we're going to see that one a lot more often, but we'll throw that one in there. Or maybe we might do a third, I don't know. So it's either 2 cards or 3 cards. We kind of have to just make a decision about what we want to have. And yeah, these are definitely not, like, the first time you make 3x5 cards, it's not always a perfect process, but it's a way for us to start to get things down, and then you, like, use them to create maybe, like, a study sheet for yourself, or, and I'm going to show you guys what I think I would probably do with these 3x5 cards if they were mine, like how I would use them to study. I'll demonstrate that in just a second. Are you guys, are people ready for me to scroll to the next one?
Yeah.
Okay, so then we kind of have some decisions to make, like how we want to do this next part. Like, you definitely want a side that says, like this side I kind of say is dedicated to the reason side. So having something that says perpendicular lines form congruent, whoa, that's not the right symbol, congruent right angles is a statement that we want to unfortunately have to put to memory, okay? So, like, what could be on the other side? It could be a number of it could be a picture, it could be exactly what we were given in this example, or it could just be a perpendicular symbol, you know what I mean? Like, you have to decide how much you need on the other side. So, I mean, I might even just, I don't know. Like, I'm kind of like wondering if we should just wait. Like, we're going to need that for when we get to page 12, we'll need that. But I mean, you can just, I don't know, whatever. We'll just put the things we have there. Okay, so BA is perpendicular to AC. I mean, that's like the card that we needed it for. Well, we didn't really need it for, but anyways. And because we had 2 angles that came out of this. DC is perpendicular to CA. Okay. And this is from page 10. So this part is not going to be 100% perfect. it's more the idea of when you're given any sort of perpendicular symbol in a given, you can say that you either have a right angle or you have congruent right angles, right? It kind of depends what you need to do. So that's where it's a little bit rough. The other thing I was just thinking about that we might want to do for a card is, and once again, I'm not grading you for these are for you. But if I were to make a card, I'd probably want one for HL, and I might just put like HL on one side, HL, right? And what do I need to do HL as a triangle congruency? The thing that kids forget to do is they forget to have, you need to say that triangle 1 and triangle 2 are right triangles, because they have right angles. So that comes up more in like a multiple choice idea than it comes up in a 2-column proof idea, but I think it's something that you should kind of hold on to, that it's the one thing that's a little bit different between the congruency statements or congruency needs. Okay, so the way that I would choose to use these 3x5 cards, so I'm just going to give you an example. I mean, the first thing I might do is just hold my cards and look at the reason sides and just read them over and over to myself, because I need to be able to put down perpendicular lines form congruent right angles. Perpendicular lines form congruent right angles, right? I need to know that wording, so I might just be reading that one side over and over again, just to kind of get that glued in my head. Then the next stage of that is looking at the opposite side and being like, oh, I see this in my given. Oh, that means I need to know perpendicular lines for congruent right angles. Okay.